geobyte.
Let us take the another important problem asking like this. The appropriate depth of an ocean is 2700 meters. Depth of the ocean, let that is D, 2700 meters. The compressibility of water is compressibility compressibility equal to 45.4 into 10 power minus 11 Pascal inverse. That means 1 by Pascal inverse. And density of water is 10 power 3 kg per meter cube. Density of water. This is the standard value for water. Though it is not given, you can take 1000 kg per meter cube. 10 power 3 means 1000 only. What fractional compression of water will be obtained at the bottom of the ocean? What is the fraction of compression in water is happening because of the compressibility nature of the water. Then fractional compression. Let me write it clearly. Fractional compression of water at the bottom of ocean equal to compressibility multiplied by pressure. Let us take another slide. So fractional compression of water is asking fractional compression of water, fractional compression of water equal to so compressibility C into pressure. Compressibility C into pressure P equal to what? Rho of water into G into depth of the water. Compressibility. Look at the compressibility given 45.4 into 10 power minus 11. 45.4 into 10 power minus 11 into density 10 power 3 G10 into D value given 2700. 2700. It is equal to 45.4 into 10 power minus 11 into 27 into 2030, 10 power 6. 10 power 6. So 45.4 into 10 power minus 11 into 10 power 6 into 27. It is 45.4 into 27 into 10 power minus 5. Minus 5. You simplify this value for getting 1.2 into 10 power minus 2. 1.2 approx 10 power 10 power minus 2. That is the answer. That is the fractional compression of water at bottom of the sea. Bottom of ocean. Understood clearly? So it is 1.2 into 10 power minus 2. Option C is absolutely correct. Okay? Yes. Similarly, let us take the another important problem. Okay? Look at the screen. It is asking like this. Copper of fixed volume is drawn into wire of length L. When this wire is subjected to a constant force, the extension produced in the wire is delta L. Which of the following graph is a straight line? Okay. It is given that volume is remaining constant. Volume equal to constant and it is having the length L. Change in length delta L. That means L equal to original length. Original length. Delta L equal to change in length, change in length. Constant force, force is remaining constant. Okay. Then you are asked to find the relation between length and change in length. For that, as you know, the change in length, the change in length delta L equal to F L by A Y. Here Y remains constant because it is a material constant. Property of the material, Y remains constant. Area is not constant. Okay. For that, we need to write area in terms of volume. Volume equal to area multiplied by length. From this, area equal to volume by length. So it is equal to F L by volume by length into Y equal to F V Y by L square. Here F is constant, volume is constant, and X modulus Y is constant. From this I can write that delta L equal to a constant into L square, constant into L square, or change in length delta L is proportional to square of the length. Look at the option B. Option B is absolutely correct. Understood clearly? Yes. Then let us take the another important problem asking like this. The following four wires are made of same material. Same material means Young's modulus Y remains constant because it is a material property. Which of these will have the largest extension when the same tension is applied? Same tension applied means force remains constant. Length given, diameter given for all the cases. For that, we need to decide the change in length. Change in length delta L equal to what? F L by FL by A Y A Y. Right? It can be written as F L by A equal to what? Diameter given in circular one. 5/4 into D square is the area into Y. It is equal to 4 F L by 5 D square L. Here F constant, 4 constant, D square Y, not L. D square Y, D square Y. Therefore, change in length delta L is equal to 4 F by 5 into Y into L by D square. L by D square. From this, I can write that change in length is proportional to L by D square. L by D square. Now, let us take the different cases. Different cases. For the first case, right? Delta L by L, delta L equal delta L for A, option A, delta L for A equal to length is how much? 50 centimeters. I am writing 500 mm divided by D square, D proportional to D square. 1 minute. Okay, a constant into 1 minute. Let me write it clearly. A constant K into D square is how much? 0.5 whole square. Next, delta L for B equal to constant K into length is how much? 100 centimeters. That means 1000 mm by D square, 1 square. Similarly, delta L for the C, option C equal to 2000, which is in centimeters. Constant K into 2000 by 2 square. 2 square. Delta L for the D equal to constant K into 3000, which is in given is centimeters, but it should be written in mm by 3 square. 3 square. Now simplify all these cases. Definitely you will find that delta L for A is the largest value. It is asking the which of the following will have the largest extension. Therefore, option A is Absolutely correct. That means 500 by 0.5 square is more than other values. Otherwise, you can write it. Here it is 500 by zero point 0.5 square means 1 by 2 square. 1 by 2 square. It is 500 into 4. Here it is 1000. Here it is 2000 divided by 4. It is 3000 divided by 9. Now, first case is 2000. Second case is 1000. Third case 500. Uh, correct, fourth case, option D, 3000 by 9. 3000 by 9. It is 1000 by 1000 by 3. 1000 by 3 is 333. So, among all these, you can say that 2000 is more than 1000, more than 500, more than 333. Therefore, option A is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important problem. Oh, completed. I hope all of you clearly understood all the problems what we discussed for this mechanical properties of solids. Understood or not? Yes. Thank you. Thank you for watching. Okay? Yes.
Geobyte.